Okay, so it's time to move on to this origins of Docker lesson. And really, this is a lesson about how Docker works under the hood. So, why do we care about Docker again? Well, we care about Docker because it allows us to set up our coding environment or a development or production environment. And this automation of an environment allows us to use a technology like Ghost and essentially just download it and not have to worry about any of the configuration and be confident that it will just work. So how does Docker achieve something like that? Well, a main step is that Docker tries to keep the software that runs something like Ghost isolated from the rest of your machine. So how isolated are we talking about? Well, before Docker, the alternative was to use what's called a virtual machine. So this is an example of a virtual machine. And what you can see is that we have a Windows operating system running inside of a Macintosh. And the way that this would be an alternative to Docker is you would essentially start from square one and say, let's just install Windows, and then go through the steps until you got to, now we have installed and set up Ghost. So you go through all those steps of downloading Python, of downloading Node, of downloading the database, and you can be sure that things will just work because you're working on an isolated Windows machine where you started from scratch. To me, I think of this a little bit like if a scientist is running an experiment in the lab, they probably want to start off with a pristine environment, nothing in the room, and then they slowly add different components so that they can run the experiment. That's essentially what a virtual machine is doing. You start with nothing in the room, clean Windows or Linux, some other kind of environment, and then you slowly add these different components until finally you have a website. So just to get a couple of terms out of the way, we refer to the laptop that's hosting the virtual machine. I gave it away. This is called the host. And the virtual machine itself, that's referred to the guest. So the guest is using the host's hardware in order to be running. And the host is what's directly interacting with your laptop, with the hardware. All right, so some downsides of this. Well, one is just, as you can imagine, it takes a good amount of space to run a separate virtual machine, a separate entire operating system, every time you want to run a task. So this can really become an issue if, for example, it's not just a website you want to boot up, but also a chat application. We may want a separate isolated environment for both a chat application and our website, but do we really want a whole separate virtual machine for each of these different components? And it's not just the space that causes an issue. If you boot up a machine, if you boot up Windows or you boot up Mac, you know that takes some time. So it's both this space inefficiency and also this time inefficiency that hopefully Docker can help solve. And the part that we want to keep is we want to keep our different components isolated so that we can be confident that they simply work. Okay, so how does Docker allow us to achieve something like this? Well, what Docker does, a trick that it kind of plays, is it actually allows us to share resources and allows different components, for example, this blogging application, this chat application, to share the same underlying software while ensuring that they do not conflict with one another so that they simply appear isolated. So how does something like that work? Okay, so it uses a Linux technology called a union file system. So let's explain how a union file system works. So union file system actually comes from like the days of CDs. And what we show here is that, we really like Harry Potter. So we borrow Chamber of Secrets from our friend and we get it from a CD. And we happen to have Sorcerer's Stone already on our hard drive. So the first feature of a union file system is that even though Chamber of Secrets lives on a CD and this lives on our hard drive, we can make it appear that they both live in the same directory and on our computer, even though one of them actually lives elsewhere. So that's the first feature. Union file system allows our folders to act as if they contain certain files, even when the files actually live elsewhere. Now let's say that we borrowed the CD, we have Chamber of Secrets on our computer, but we want to change, let's say, the first page of the book. Now, if we just went ahead and changed the first page of the book and then gave that CD back to our friend, they would be pretty annoyed with us. So instead, with the union file system, what occurs is that we actually copy that first page and then make the edits on the copy and then layer that copy on top. So what this achieves is, for us, because this is layered on top of the file we wanted to copy, it looks like we have made the change to the original. But really, we've just layered this on top. So for our friend, when we hand back the CD, nothing has actually been changed. So this is the second feature. A union file system applies what's called a copy on write. So whenever we want to actually write or change something to a file, the union file system will first copy the file, and then we will edit the copy, and then we will read from the copy instead of the original. Meanwhile, the other piece of software that's relying on it, they are viewing the original. So how does this work with something like Docker? Let's go back to our chat application and our website application. So you can see what I wrote down is that, okay, like both Ghost and the chat application are both using Node and SQLite3. That's fine, right? As long as they're both using exactly the same thing, that's totally fine. But then let's say that we want to modify something in Node for the Ghost application. We want to make sure that this modification doesn't affect the chat application. So instead what we do is we copy that file, let's say it's index.js, and then we write to this copy. The index.js file that still lives in the Node application, right, this is untouched. In fact, we never touch the index.js. Instead, what we are touching is a copy of the index.js file. So this is how Docker, through a union file system, can allow us to both share resources across different applications, yet make it appear as if they are isolated, and make sure that modifying something in one application does not affect the other application relying on that same software. What's cool, I think, is that like when you download an image, you can sometimes see those layers. So for instance, if you did download pull ghost or Docker pull ghost, lots of times you'll see something like this, where you see, oh, this already exists, this already exists, this already exists, right? These are different layers of an image that maybe are used by the chat application. And maybe this represents Python, and this represents Node, and this represents React. If we already have these downloaded, Docker doesn't need to re-download and use up more space on our computer. So we see this with an image, how Docker uses this like layering on top of files and just using shared resources across different images. This also occurs when we booted up a container. So remember, we booted up a container, we did something like Docker run ghost, and I guess I don't have Docker running right now, but we had said something like Docker run ghost. And remember, it then created all those different tables and did all those different procedures. So what does that really mean when we're booting up a separate container? Well, really, if this part right here is our image, right? It's all those layers, just files being layered one on top of another. And a container is really just another layer on top of the image that's writable. Okay, so when you're booting up the software, well, you want to be able to interact with it. So what does Docker do? It adds another layer on top and allows you to interact with that writable file. So that's what a container is. And we'll talk more about images and containers along the way. One other thing we should talk about is that it's not just the files that Docker achieves isolation with and avoids conflicts between our different applications. It's also with the processes. So when you boot up a website like Ghost, lots of times you're running it on a specific port. If you boot up a chat application, that's also running on a port. A port is just a location on the computer. The issue comes into play in what if the chat application and the blogging application are both running on the same port on our computer, right? So maybe the chat application is running on 2368 and the blogging application is also running on 2368. Remember, the point of Docker is, all right, we're just going to download this software, do Docker run, and hopefully this will just work. So we're not going to pay attention to these internals. But of course, we're going to run into a conflict because they're both trying to run on the exact same space. So the way Docker avoids this is whenever you're running a process, it really runs that process inside of what's called a namespace. What's a namespace? It's just a folder, okay? So it may look like you're running the chat application on port 2368, but really you're running it inside that folder, which is really inside this container, okay? And it's isolated from any other container or even from the rest of your computer. Same thing with the blogging application. It may look like it's running on port 2368, but really it's running inside this blogging application folder. And we saw that, by the way. Remember when we tried to do the Docker run and access the website directly? The reason why we couldn't access it is because it wasn't running on port 2368 on our computer. Instead, it was running on it inside this folder.